Okay, so it should pick up on this problem right here, multiple choice. And you need to change it into vertex form. So the vertex form is y equals a x minus h squared plus k, and you got to use this idea that we just did right here of completing the square. So you know you're going to complete the square because if you try and factor it and find your roots, 13 and a negative 10, well, it's going to multiply and give you 13, but add and give you negative 10, and 13 is prime, so there are only two numbers, 1 and 13, and there's no way you can use a 1 and a 13 and get a negative 10. So completing the square is what we're going to do. You're going to take x squared minus 10x. This 13, you're just going to scoot it over. You can't get rid of it, but you can scoot it over. And now you can replace it with a number of your own choice. The number that we want to replace it with is going to be something that adds and gives you negative 10, and you want it to add itself, so it's going to be negative 5. You just cut it in half, and negative 5, and then it's timesing to give you 25. So the number I want is a 25, so I'm going to go ahead and put a 25 there. But the very moment you put 25, you must take it right away. So if you're going to add 25, you got to subtract 25, because that is adding 0. And if you add 0, you don't even change it. So x squared minus 10x plus 25, if you factor that, that's going to be x minus 5 times x minus 5. And that is my perfect square. That's what I want. That is going to be x minus 5 squared. And then these two guys, let's combine those. What's a negative 25 and a 13? That's going to be, I got more negatives than positives, so it's going to be negative 12. Okay, now if you have to if you got to graph this, it's now in vertex form, so it's easy. My vertex is going to be a negative 5, so that's telling me to go right 5 and down 12. So right 5 and down 12 is just barely off the graph. So I went right, oh, this is my x, this is my y. I went right 5 and I went down 12. So I'm going to try going right 4. So 4 take away 5 is 1. 1 squared is 1. What is 1 minus 12? That's a negative 11. So go over 4 and down 11. This dot's for free right there, and you have a parabola. So not too bad. Okay, let's look at these two problems. The first one, what is the vertex if they give it to you in factored form? So it's in factored form. Let's just see if we can graph it and figure out where that vertex is going to be. Okay, if it's in factored form, I'm after the zeros. I want 0 for my answer. So I want the answer to be 0. The question is, what do I plug in to make the answer 0? I'm going to plug in for x, I'm going to plug a 5 there, because 5 take away 5 is 0. And I'm going to plug a minus 2 there, so minus 2 plus 2 is 0, so minus 2. So 5 and 0 and a minus 2 and 0. So somewhere over here, there are my zeros. I know my vertex has to be halfway between them. So I'm going to find the average of them. I'm going to find the average of 5 plus a minus 2. That's 3. Divide that by 2. That is 1.5. So at 1.5, my vertex is going to happen somewhere on that line. So I can now kill A and B because they say it happens at negative 1.5. So now I'm going to take 1.5 in calculator and I'm going to plug it in there for x. Plug it in there for x, copy and paste that, and press enter. So I'm going to type in 3 parenthesis 1.5 minus 5 close parenthesis 1.5 plus 2, and I got a, when I plugged in a 1.5, I got a negative 36.75. So now I'm feeling pretty good about C. Okay, 20. What is the vertex of this one? This one's in vertex form, so this one's easy. This plus 4 tells me to go left 4, up 3. So left 4, up 3. Right there's my vertex. My vertex has to be B. Left 4 and up 3. Okay, that does it for the quadratics and the graphing. The last few weeks we've been doing radicals. We've been simplifying radicals. So, let's start remembering everything we know about radicals. The first one, what we need to do is bust up 128 into its prime factors. 128 can be written, it's even, so I'm just going to start hacking it in half. 128 divided by 2 is going to be 2 and 64. 2 is done. 64, I'm going to go 8 and 8. And I know each 8 is a 2 and a 2 and a 2. A 2 and a 2 and a 2. So it looks like 128 is just a bunch of 2's. So I'm going to change it to 2 to the 1 to 3, 4, 2 to the 7th times m to the 5 times n to the 10. Okay, now it's under a square root, and a square root is going to undo any squares. So the long way of looking at this is a negative 7 is rewriting all these as squares. I have a total of 7 2's. So I can write that as a square, a square, a square, and 1 left over. That gives me 7, because 2 plus 2 plus 2 is 6 plus 1 is 7. So you can either write it out the long way, or you can just ask yourself, how many squares are there in 7? How many 2's are in 7? And there are 3 of them. And this square root is going to undo each of those squares. So on the outside I got a negative 7. And anything that gets undone is going to be multiplied to this negative 7. So I know that each of these 2's is going to get undone. So it's going to be, I'm going to have 3 of them out there that get undone. And on the inside, this one stays under. Not enough for him to become undone. M's, I have 5 M's. How many squares are there in 5? How many 2's are in 5? I know that 2 of them get out. They get undone. So 2 squares is 4, but I had a total of 5, so there's going to be 1 left over. How many squares are there in 10? And there are exactly 5 squares with none left over, because 5 squares is 10. So my answer, this 2 times 2, that's really 8. 2 times 2 times 2, 8 times negative 7. My answer is negative 56 m squared n to the 5th times the square root of 2m. The next one, 343. Let's start breaking it down. 343 divided by 3. It's not even, so you can't divide it by 2. 3 does not work. 343, don't try 4, don't try 5. Try 7. Okay, it's going to be 7 and 49. 7's done, and a 49 is a 7 and a 7. So it looks like it's all 7's. So it is going to be 6 times the square root of 7 cubed x cubed y to the 4th. So what gets undone and what does not get undone? How many squares are there underneath this? So let's look at the 7. I got 3 of them. So I've got 7 cubed. How many 2's are in 3? 1 of them. So you can rewrite it as like 7 squared times 7 to the 1. But this 7 squared gets undone, so the 7 on the outside with the 6 is going to give me a 42. But what else gets undone? The same with the x. 1x comes out. And how many 2's are in all those y's? I got 4 of them. There's 2. So y squared gets undone, and on the inside I'm left with a 7 and 1 left over x, and that's it. So my final answer is going to be 42xy squared times square root of 7x. Okay, the next few. Now we're going to start to do add and subtract, times and divide, and that is where we have left off right before Christmas break. So now this one is a kind of an add problem. So negative 2 square root of 18 plus a negative 1 square root of 8. So in front of the square root of 8, there's kind of an invisible 1. Okay, the 18 I know is going to be a 9 and a 2. And a 9 is a 3 and a 3. So I'm going to rewrite this. I'm going to come up here. Negative 2 times the square root of 3 squared times 2. So that 3 gets undone. And it multiplies the negative 2 that's already on the outside. So it's going to be a negative 6 square roots of 2. And a square root of 8 I know is a 2 and a 2 and a 2. Square root of 8 is 2 cubed. So one of the 2's comes out and one of the 2's stays in. And now, because they are both square roots of 2, they are like terms and you can add them. And you only add the numbers in front. So negative 6 and a negative 2 gives you a total of negative 8 square roots of 2. And that is your answer. Okay, let's look at this one. 45. It's a big number, so there's some squares in 45. 9 and 5. 9 is a 3 and a 3. So you're going to rewrite this as 2 times the square root of 3 squared times 5. So that's going to be, this 3 gets undone, times the 2, so it's 6 square roots of 5 plus 2 square roots of 5, and that is going to be a total of 8 square roots of 5. Done. Okay, what about multiplication? Multiplication, you multiply what is on the outside together. So negative 4, that's invisible 1, so that's going to be a negative 4. And you multiply what's on the inside together. So a 2 and a 2 is going to give me 2 squared. An n cubed and an n squared is going to give me an n to the 5th. So now, the 2 gets undone. And how many squares are there in 5? There are 2 squares in 5, so 2 of these n's get undone. So it's going to be a negative 4 on the outside times a 2 gets undone times n squared, but 2 squares is 4. There was a total of 5, so that means one of them stays in. So your final answer, negative 8 n squared times the square root of n. Okay, this is it. 5 more problems and we are done. So this first one, let's multiply these together. So my negative 3 and my negative 4 is going to become a positive 12. The next, you can multiply the 2 and the 15 and get 30. And then you can break that down. 30 is a 10 and a 3 and a 2 and a 5. Or you can break it down here, a 2. And if I break down the 15, that's a 3 and a 5. So it looks like I just have one of each, a 2 and a 5 and a 3. I've got to have more than one. I got to have 2 or more for them to get undone. So it looks like 30 is as done as it gets. So my x's, I got 3 of them. So I know I got enough x's that I can clean up my x's. So on the outside, I got a 12. And if I have 3 x's, square root is going to undo any squares. That's going to undo an x squared. So I've got x on the outside, and then on the inside, I've got the 30x. Okay, now division. So you divide what's on the outside together, and you divide what's on the inside together. So 4 divided by 4, that's just 1. But 6 and 50, they're both even. I can divide them both by 2. So if I simplify 6 and 50 and I change that to 3 and 25, that's perfectly legal. But now you're in luck because you've got this memorized. The square root of 25, that's just a 5 and a 5. 5 squared. So, on top you got square root of 3. On bottom, you have got 5. And the next one, 5 and 2 do not divide. They got nothing in common. So your answer is going to be a 5 and a 2. 8 and 9 got nothing in common. But the square root of 9, that's a perfect square. That's 3. So it's a 2 times a 3 on bottom. And on top, it's a 5 times the square root of 8. So on top, I've got 5 times 2 cubed. Because I know 8 is a 2 and a 2 and a 2. And because I've got 2 or more, I know that that square root is going to undo a square. So on the outside I got a 5 and a 2. And on the inside I got a 2. And on bottom I got 2 times 3, that's 6. On top I've got 10 times the square root of 2. On bottom I got 6. Now I'm going to clean these up. 10 and 6. They are both divisible by 2. That's going to be a 5 and a 3. So that is your final answer. Okay, these last two, these are going to divide each other, 2 and 2, and that 2 divided by 2 is just 1, so my answer is 1 over square root of 2. But it is unacceptable to leave a square root in the denominator. So we need to fix it. We need to change this into a rational number. So I'm going to multiply this by 1. And I'm going to create this into a perfect square. Square root of 2, if I times it by square root of 2. But I got to do it both to the top and the bottom because this is just 1. Anything divided by itself is 1. So I can times by 1 and not change it. But if I times these together, I create square root of 4, which is a perfect square. So square root of 4 on bottom, that's going to change to 2. On top, if I times these together, that's going to be square root of 2. Okay, last one. I can divide these together. 2 divided by 2 is just 1. And I can even divide these together. And 2 divided by 6, that's going to be the same thing as 1 divided by 3. Okay, now this one I like. Square root of 1 is just 1. So I've got 1 over square root of 3. And we're done. But it is unacceptable to leave a square root on the bottom. So I need to change that into a perfect square. 1 times the square root of 3. If I multiply it by 1, if I multiply it by square root of 3 over square root of 3, on top that's going to give me square root of 3. On bottom that's going to give me square root of 9, which is by design, that's what I want. Because square root of 9 is just 3. And on top, I got square root of 3. And we're done. So, that was a lot of material in 1/4. You guys covered quite a bit of ground. It should feel pretty good because that's a lot of brand new stuff you learned. And that should make you feel smart. So study up, do good on the test, and be happy.